in the report it came as positive.
Like when you reached Kingdom, at that point you.
Yes, sir. That time it came positive, but after that they informed us that the report was changed with someone else.
Do you need to quarantine if you reach Kingdom, or you don't need
Sir,
to?
if we are vaccinated in Kingdom only, like both the doses, then there is no
Mm-hmm.
quarantine if you're vaccinated.
Okay,
But
okay,
if
okay.
we are vaccinated from any other country, then 5 days quarantine.
5 days quarantine. So you can quarantine at any place, or you need to quarantine at some specific place?
There are specific hotels, sir.
You have to pay for the hotel?
They're included in the ticket itself, the flight ticket.
So that means you have to pay, right?
Yes, sir.
That is the same thing I heard like in Qatar also. But in Qatar, I think it is not 5 days. It is like a bit longer, 14 days or something. I don't know exactly. And those hotels are also very expensive.
Yes, sir.
Okay, fine. So you guys are vaccinated in Kingdom, so you did not need to. But in Qatar, it is not like that. In Qatar, even if you are vaccinated in Qatar, then also you have to quarantine if you are coming from any other city. Even though the reports are negative, still you have to quarantine. Okay, fine. Let us move on to chemistry. And what we were doing, we did in the last class, we ended up with the equation like this: that rate of forward reaction is equal to the rate of backward reaction at equilibrium. And then we wrote some equations. So we will just write those things in our notes in more what can I say, more organized format, and write law of mass action. First of all, the law of mass action. So law of mass action, it is the idea that if I have A plus B, reactants A plus B, and it is giving me some products C, so the rate, it will be directly proportional to the concentration of A multiplied by the concentration of B. Now, if I have 2A, which is giving me some product C, then you may be tempted to write that the rate is directly proportional only to the concentration of A. But please remember that when we write 2A, it is just a mathematical way of saving space. No, originally it is A plus A. So again, we have two reactants, and both of the reactants are A and A. That is why if I have 2A, that means I can say that rate is directly proportional to the concentration of A square raised to its stoichiometric coefficient, So keeping this idea in mind, we will write the law of mass action. Okay, so we wrote this now: rate is directly proportional to the concentration of the reactant raised to their stoichiometric coefficient. That is the rate law of mass action. That is the law of mass action. So please write with me. Here. The rate of a chemical reaction. The rate of a chemical reaction is directly proportional to the product of concentration terms okay, Atif, okay, concentration terms raised to their stoichiometric coefficient. Okay, so for a general reaction AA plus BB, where uppercase A and uppercase B are the chemical species A and B, lowercase a and lowercase b, these are the stoichiometric coefficient of the chemical species A and B respectively, will give me C plus DD. So for this, I can see the rate is directly proportional to the concentration of A to the power A multiplied by the concentration of B to the power B. And for this, I can eliminate this proportionality sign, write an equal to sign, And then I can say this is K some constant, which we see as rate constant multiplied by the concentration of A to the power A at the concentration of B to the power B. Okay. So write this down. Atif, let me know if you're done. Okay. Write this down, Atif, and let me know if you're done.
Yeah, done, sir.
Done? Okay, fine. Can you read the question in assignment?
1 minute. Sir, the question is, a liquid is in equilibrium with its vapor in a sealed container at the fixed temperature. The volume of the container is suddenly increased. A, what is the initial effect of the change on vapor pressure? B, how
Okay,
do
okay,
rates of
okay,
evaporation?
wait. Okay. So first of all, is there any word that you don't know the meaning of in the question? Till
No,
till where
sir.
you have no, you know the meaning of all the words.
Yes, sir.
Okay, you understand what is happening. You have kept something. I think we did this example, right? Yes or no in the class? That we increase suddenly the vapor, the volume. Yes, Atif, do you remember?
Yes, sir.
You remember this, right? Acha, fine. So in that case, we took what? They have not said water till now. So there is some liquid here. There is some liquid here. Now, if nothing is happening, then after a while, what will happen? The rate of, there are two things happening. The liquid, it is getting converted to vapor. Okay. This will come in equilibrium with the liquid, which is the vapor, which is condensing. The vapor, which is condensing to liquid. There is two things which is happening. So there is the rate of vaporization. It will be equal to the vapor. It will be equal to the rate of, sorry, if I am writing the rate, this would be equal sign, not, this will be equal to the rate of condensation. Okay. So these two things are in equilibrium, because if you close a vessel, then you will see that the water, it doesn't get evaporated. It will get some water will get evaporated, but then it will become a constant. Acha, one more thing I told you guys to tell me about how evaporation happens. Did anyone search about it? Atif, Abhinav, Muhammad Umar, Najib, Reba, anyone? Surat? No. Okay, no problem. Let me explain this first then. Atif, can you please keep the mic on? Atif?
Yes, sir.
Yes, okay. So do you understand this point? Rate of vaporization is equal to rate of condensation?
Yes, sir.
Okay. At equilibrium, right? After William. Then what we are doing? What change we are doing?
Sorry, sir.
We are changing something, no? The liquid and the vapor are in equilibrium. After that, what we are doing?
Increasing the volume, sir.
Increasing the volume. Okay. Now, if I increase the volume is increased, and that will lead to a decrease in pressure. Correct?
Yes, sir.
This will lead to decrease in pressure. Then what will happen? Let me show you like this. If I have increased the volume like this. Now, how is condensation happening? The water vapor, they are striking down, they are striking on the liquid water, okay, liquid water, and the liquid water is taking up the water vapor and it is getting converted into what? Now this temperature will be a bit low. So when it strikes the water here, it strikes the water, and what happens? It becomes the water liquid, okay, it becomes liquid rather than vapor. So if I increase the volume, then the chances of these vapors striking the surface of water, it will decrease. Yes or no? Tell me that. If I have,
Yes, sir.
if I have a very closed vessel, then the chances of water vapor striking the surface of water and getting converted to water liquid, that is very high. But if I increase the volume, then the rate of condensation will decrease. Yes or no?
Yes, sir.
But the rate of evaporation or rate of vaporization is constant. It does not know. Rate of vaporization has nothing to do with the volume change. But what will happen? The rate of condensation, it will decrease. Now slowly what will happen? If the rate of condensation has decreased, the rate of vaporization is similar, then more and more water will be formed. More and more water vapors will be formed. Yes or no?
Yes, sir.
Okay, so you got the answer for the first or second statement, right?
Yes, sir.
So rate of condensation will decrease, rate of vaporization will be constant. What is the third question?
So what happens when equilibrium is restored finally, and what will be the final vapor pressure?
Okay, so when the equilibrium is restored, that means you just keep it like this. Okay, you increase the volume, and then you came after 10 hours. Then what happened? So that is the graph that I was talking about. The vapor pressure is constant. This is the pressure here. Then when you increase the volume, we know that pressure is inversely proportional to volume. So the pressure will decrease, the rate of condensation will decrease, and so rate of vaporization is more than the rate of condensation. So more and more water will be formed, more and more vapor will be formed. And if more and more vapor is forming, then what is happening? Slowly it will start to increase, right? The vapor pressure will start to increase slowly, and then it will slowly reach the same initial vapor pressure. Okay, the original vapor pressure after achieving equilibrium. है ना?
Yes, sir.
Okay, fine. You wrote this, na?
Yes, sir.
Rate. Okay, fine. All right, the next topic, that is law of chemical equilibrium. Chemical equilibrium. Okay, so law of chemical equilibrium will start with the general reaction, that is AA plus BB. This is an equilibrium with CC plus DD. CC plus DD. Now, for this, I will write two reactions. First, I will write the forward reaction. So can somebody tell me what is the forward reaction here really fast? What is the forward reaction here? Are Reba, Surat, anyone? Forward reaction, Reba? Don't know? Atif?
Sir, AA plus BB gives CC plus DB.
Yeah, that's right. AA plus BB is going to give me CC plus DD. So I can write the rate is equal to, I will write a rate constant, that is K, small k, okay? K forward, okay? Small k forward into the concentration of A raised to the power A into the concentration of B raised to the power B. Similarly, I will write the backward reaction. Here, what will be the backward reaction? CC plus DD is going to give me AA plus BB. Yes or no, guys? Tell me. Yes or no?
Yes, sir.
Yes, okay. And here, what will be the rate? Rate will be equal to KB, K of backward. Tell me. What should I write here?
C raised to C plus C raised to C into D raised to D.
Yeah, C raised to C into D raised to D. C raised to C. Okay. Now, we all know that at equilibrium, well, I can write this as rate of forward. This is the rate of backward. At equilibrium, we have the rate of forward reaction. It is equal to the rate of backward reaction. Okay, it is equal to the rate of backward reaction. Hence, for forward reaction, I can write K forward times AA into B to the power of B. It is equal to K backwards into C to the power of C and D to the power of D. Now, I will write K forward divided by K backward. This will be equal to the concentration of C to the power C, the concentration of D to the power D, the concentration of A to the power A, and concentration of B to the power B. Now, since both of these are constant, both of these are constant. For both of these constant, I will write a big constant, that is capital K, which is equal to C to the power of C, D to the power of D divided by A to the power of A into B to the power of B. Okay, now this K, it is known as this K here. This K, it is known as the equilibrium constant. This K, it is known as the equilibrium constant. Okay. So what is the equilibrium constant? The products of, sorry, rather I should write the ratio of the products, the ratio of the product of products of a chemical reaction, rather no, the ratio of products of concentration the ratio of product of concentration terms raised to their stoichiometric coefficient of products to the product of concentration terms raised to their coefficient of reactant is constant at equilibrium. Equilibrium means after a very long time. Okay, equilibrium means after a very long time. This constant is known as the equilibrium constant. The equilibrium constant. Okay, so what are we saying? We are saying It is the ratio. It is what? It is the ratio. Ratio means, wait a second, let me write this in some different color. Let me write it this. Ratio. That means this is a ratio. So this line, so what I am doing, what I have written now, I am trying to represent that by highlighting in the equation. Okay, so this is the ratio of product of concentration terms raised to their stoichiometric coefficient of products. So this is the green part. The concentration terms का क्या है? Product है. It's the product of the concentration term raised to their stoichiometric coefficient. है ना? 2. That means ratio होगा तो 2 होगा. Ratio of this to that. Okay. To the product of, use some other color, to the product of concentration terms, है ना? Concentration terms raised to their coefficient of reactants. So ratio of products to reactants. So this is the reactant part here. Okay. It's constant at equilibrium. This constant is known as what? This constant is known as the equilibrium constant. Okay, it is a constant at equilibrium. So this K is equal to constant. Okay. So you may also write that E here, small e. What does it mean? This means equilibrium concentration, not initial concentration, not final concentration, equilibrium concentration, not the concentration in which the change is happening. The concentration after a very long time. Equilibrium means after a very long time, what is going to happen? So this E sign, the subscript E, it is optional. Okay, you will never see this in many of the books. Okay, but please, in your mind, you should keep it that K is equal to the concentration of the product of the concentration of product to reactant at equilibrium. Okay, equilibrium concentration. Write this down. Let me know if you're done. Let me know if you're done. Okay. Write a question. Write the. Achha, wait a second. Let me also tell you one more point here. The equilibrium constant can be expressed in two ways. Can be expressed in two ways. Number one is by molar concentration. By molar concentration. So by molar concentration, we write Kc, which is equal to the concentration of products divided by the concentration of reactants, both raised to their stoichiometric coefficient. And I'm writing, see, the sigma sun is for summation. If you want to do sum, there's a pi sign for the products. So the product of the concentration of the products and the product of the concentration of the reactant raised to their stoichiometric coefficient. We can also express, if we have only gases, for reactions involving only gases. Now we can also write Kp, equilibrium constant, in terms of pressure. So this will be equal to the pressure of A to the power A. I can write it like this. The pressure of products raised to their equilibrium constant, sorry, raised to their stoichiometric coefficient, unka product divided by the product of the pressure of reactants raised to their equilibrium, sorry, raised to their stoichiometric coefficient. Okay, so these are the two ways, Kc upon Kc and Kp. I will give examples that will make you understand more. But first, please write this and let me know if you're done. please make sure that you are using Kp only when all the species involved in the reactions, they are gases. Let me know if you're done. Hi guys.
Done, sir.
All of you done?
No, sir.
Wait, sir.
No, sir. Okay. You understand the meaning of pi, na? Huh, guys? Yes, Reba, Atif, Muhammad Umar, Abhinav. Huh, tell me, pi, you understand now what I have written? Why pi?
Yes, sir, I understand.
You understand ना? Okay, हाँ. ऐसा कोई नहीं, बीच में देखा पाई यहाँ पे आ गया तो फिर पाई लेके आने लगा, यहाँ पे फिर 22/7 भी लिखने पड़ते. This is not 22/7. Okay. Reba, what is this pi? Oh my God. Reba, what is that pi? Pi is not 22/7. It denotes.
8.14.
Bond.
अरे भाई नो, वही हम बोल रहे हैं, इन लोगों को समझ में आ गया. Sigma of I, sigma of I, where I is equal to 1 to 10. So what does this mean? It means that 1 plus 2 plus 3 plus 4, na? Tell me.
Yes, sir.
Okay, so similarly you have pi. Pi is for products. Pi of I, and I is equal to 1 to 10. So this means 1 into 2 into 3 into 4 and so on. Till this will be till 10 and this will be till 10. Guys, now you tell me, Atif, Muhammad Umar, Reba, you got it now? What is pi?
Yes, sir.
है ना? Pi means product. 3.14 22/7 pi bond. No, that's not. Let me write this in a better way, because this is the uppercase pi, which is written as like this. It denotes product. Products are not products in the sense of reactant and product. It denotes multiplicative product. Multiplication as sigma denotes summation. अरे बाप रे बाप, इतना बड़ा गुनाह हो जाता है अभी. हाँ, now you tell me, done?
Done, sir.
Okay, now you will write the expression for equilibrium constant. Write the question. Write with me, okay? Write the expression for equilibrium constant Kc for all reactions and also Kp wherever applicable. Wherever applicable. Okay. So at the first reaction, I'm doing this for you, okay? For the first reaction, NH3 gas plus 5 dioxygen gas This is in equilibrium with 4 moles of NO gas plus 6 moles of H2O gas. 6 moles of H2O gas. Okay. So for this, please don't write it now and tell me. What should I write here? Kc. In the numerator, products or reactant? In the numerator, guys. Atif, Reba, Muhammad, all of those who can turn the mic on. Surat, please keep your mic on now. And tell me. Kc will be equal to reactant or product? Look and tell in your notebook.
Products by reactants.
Products, na? So concentration of products. So tell me what are the products? NO, right?
Yes, sir.
Okay, NO. Okay, so raised to the power 4 also, right?
Yes, sir.
H2O raised to the power how much?
6.
6. Then NH3 raised to the power 4. Divided and oxygen O2 raised to the power
5.
Raised to the power 5. Okay, what will the Kp? If I want to express this in terms of pressure, I can express this now because all of these are gases, right? I can express this in the terms of pressure also. I can write this as the pressure of NO, again product, raised to the power 4 into the pressure of H2O gas raised to the power 6 divided by the pressure of NH3 raised to the power 4 into the pressure of O2 gas raised to the power 5. Okay. So you guys can do now these type of questions. Tell me.
Yes, sir.
Okay. So N2 gas plus H2 gas is in equilibrium with NH3. So you need to balance it. Okay. Please check if it is balanced or not. Then write 2 moles of NO2 gas is in equilibrium with N2O4 gas. Then you can write H2 gas, it is plus I2 gas, it is in equilibrium with 2 moles of HI gas. 2 moles of HI gas. Okay. So you write the equilibrium, you write the expression for Kc and Kp for all of these and send pic to Nishkarsh sir. Okay. Or in chat. Or in chat in Zoom. Okay, and send it to Salim, not to everyone. Those who can send in Zoom, they can send in Zoom. And if you want to send it to Nishkarsh sir, whatever is more easy, whatever is more feasible to you. Okay, you do that. And raise your hand if you have sent the answer, okay, to Nishkarsh sir or to me. Also, let me know if you're having difficulty, huh?
So in the second question is NH3 gas.
Yeah, NH3 is gas. Yeah. Okay, fine. You can ask also. Okay, Reba has sent the answer. Okay, fine. Okay, received the answer. Send. Okay. Yes. Okay, fine. Okay. Correct, correct, correct. Yes, Reba, very good. Correct. So, Reba, you're writing with black and blue pens, right?
Yes, sir.
Okay, fine. Just confirming. What about others, huh? What about you guys? Okay, Atif, you're doing?
Sir, I finished, but I made a huge mistake, so I'm doing it again.
Ah, okay. What about you, Surat? Done? Hmm. Surat, okay. Tell me, are you done or no? बाकी बातें करा लो सूरत से बस पढ़ाई के टाइम में she doesn't even speak. हाँ, what happened, Surat? Okay. You have Nishkar's phone number, right? Yes, Surat. Okay, fine. Yeah. What about you, Abhinav? Done?
Yes, sir. 1 minute
Did you?
session.
Okay, fine. And you, Muhammad Umar, what about you? Are you there, Muhammad Umar? Seems not.
Yes, sir, I'm there.
Okay. Send the answer if, to Nishkar sir, okay? Also, what about Muhammad Sheikh and Najib? Yes, Muhammad Sheikh? Say something now, then only I will be able to help you now. Najib, what about you? These guys they come here, okay? Nothing. They're just virtually present. What about you, Rishan? Rishan, you can send the answer, no? To Nishkar sir, yes or no? Yes, Mr. Rishan Mirza. Rishan is also becoming like that only.
So do you know how to send files to the Zoom chat?
You're in phone?
Yes, sir.
In phone you can't send it. So you send to Nishkar sir. I'm still waiting, guys. Atif, Abhinav, Muhammad Umar, and Surat. Surat, कितना हुआ आपका? 1, 2, B, C, D. You have 3 questions now. How many of them are done, Surat? You're doing the last one? You're still doing the last one. How is this possible, huh, Surat? I need answers from you guys, okay? Atif, you did a mistake previously, okay?
You guys need to be fast. You guys need to be fast. This question you don't have to do any calculations. So at least I would say at max I would say you should be taking 1 minute for each questions, not more than that. Raise your hand if you have sent the answer to Nishkarsh sir. What happened, Abhinav? Abhinav left only, huh? What about you, Muhammad Umar?
I'm still learning.
Sorry? Muhammad Umar, what did you say? Which question? Which question?
C.
See,
When
why?
B I
What is?
didn't understood C, I'm doing. I skipped B.
Wait a second. Wait a second. What you did not understand? Tell me. No, I'm not able to hear you. What you did not understand, Umar? You see the A question that has been done for you. You can see a pattern. Now you can see something. I mean, I don't understand what you can't. You just have to write the expression. You don't have to solve for anything. Atif, I have not received your answer till now. Why?
So Niskarsh's contact was my father's. I asked him to send. He hasn't seen the message yet.
So you asked, na? You asked me, na? Nishkarsh sir phone number. Let me
Okay,
send you.
sir.
I'm sending this to everyone who does not have his phone number. Okay, I have added the country code 919310284958. Please try to tell me what did you not understand, Muhammad Umar? Around 20 minutes you guys are taking. This is, oh God. What happened to you, Surat? Surat? Surat, you can turn the mic on, na?
Yes, I'm sending.
So, you have been sending from, I think, last 10 minutes, huh? Whose is this? I mean, in the blank white paper. Okay, this is your Atif. Okay. Yeah, that's fine. Yeah. Just write your name, maybe. Okay. Oh, okay, Atif, that is correct. But again, not very good because you guys took very long time.
No, sir, I finished before this, but sir, I made a mistake. That's why it took long.
No, still. You did some mistake, I can see. Anna? Previously, you said you did some mistake. There is no scope of mistake here. You just need to be careful, nothing else. Okay. Conceptually, this is, I mean, nothing. हाँ अभिनव आए थे तो चले गए. Okay. Surat sent. Yes, Surat. Turn the mic on and tell me. Did you send it?
Sir, it's taking time.
It's taking time. Uploading is taking time. Huh, Surat? What happened to Muhammad Umar? Those who have answered, they will only be able to understand, and I will be asking them only. Okay. I will be ignoring those who have not sent the answer. Okay, Muhammad Umar. Okay, Muhammad Umar, can you send the photo of your notes where you are writing notes? Send a photo of your notes. Now that should not take much time. Like the previous thing that we have written just now. This part.
Sir, did you receive mine?
No, I haven't received yours till now.
But sir, I've sent initially, sir.
Okay, fine. He will send it. Don't worry about that. So on which number? 9310? Surat?
I guess so, sir.
अरे देख के बता दीजिए ना ये I guess क्या होता है? 93102, the same number which I have sent in the chat, or some different number? Because he has one more number.
Yes, sir, that one.
Muhammad Umar, I asked you something. Send me a photo of your notes that you are writing. You guys took a lot of time. Lot of time means lot of time. This was a none question. You will not even get questions like this in your examinations for one. You will get for 1 marks only, maybe. You're taking so much of time. I don't know what you guys did not. What? Okay, fine. Surat, why did you take so much time? Yes, Surat. Surat, can you please turn the mic on and tell me why did you take so much of time? Muhammad Sheikh and Najib are not in class, and I don't know about Rishan also. These three people, okay. So Najib, Muhammad Sheikh, and Rishan. Okay, I haven't Okay. Suraj, did you write name? Suraj, did you write name? Array speak. I have not received. Where did you write the name, Suraj? Is there a lotus made in your notebook, like in the page and date section? Is that yours? How will I understand now? Okay. नाम तो है नहीं आपका, ये सर लिख दिया आपने. हाँ. Okay. Okay. Okay, fine. Guys, you guys took so much of time. Okay, this is very irresponsive of you guys. When did Reba send me the answer? When did I got? Okay, I received answer from Reba at around 44. Oh God, you guys took approximately 15 minutes for this answer. It was a silly question, and not. I mean, don't even have to put mind. Casey, what are the products? You write the products. NS3. How many moles of NS3? 2 moles of NS3 in the exponent in the power. Then you write the reactant N2 H2 raised to the power 3. For Kp, what you needed to do, pressure of N2, pressure of NH3, and whatever is written here to the power 2, then pressure of N2 multiplied by pressure of H2 to the power 3. Similarly, you have to do for those things. For D answer, I will tell, because I don't know why Muhammad Umar could not do the D1. You have Kc. What is the product, Muhammad Umar? Hi is the product. So the concentration of Hi to the power 2. And
I
H2.
sent it to Nishkash, but he hasn't seen it.
Okay. Fine. Now write all of you. Relationship between. I'm not going to explain this to you. Relationship between, you guys, you understand on yourself. Between Kc and Kp. Kc and Kp. Okay. So we know that Pv is equal to nRT. So pressure, it is equal to number of moles divided by volume, RT. Now we know number of moles and divided by volume is equal to what? Is the molar concentration, because moles per liter. Molar concentration, molarity, molar concentration or molarity. Molar concentration. And from here I can write what? I can write that the pressure, it is equal to the concentration C RT. Similarly, if I'm going to write for P of A, that is the pressure of A, that I can write concentration of A times R times T. This also I can write as the concentration of A in the square bracket terms, R times T. Fine. So this is how I will write the pressure. Now I will write the Kp. What is Kp? If I have a simple reaction, AA giving BB, giving CC and DD, AA plus BB giving CC plus DD, then I will write the Kp is equal to the Kp, it is equal to the concentration of C raised to the power C, the concentration of D. No, I'm writing Kp. So I have to write pressure. Wait a second. Let me reshare my screen. I have to write pressure because it is Kp. So pressure of A to the power A, pressure of B to the power B, products na, pressure of C to the power C, pressure of D to the power D, divided by pressure of A to the power A into pressure of
B to the power B. Now, for PC, I can write this is equal to the concentration of C times RT to the power C. Then I can write for D, the concentration of D, RT to the power D, divided by the concentration of A, RT to the power A, divided by concentration of B, RT to the power B. What I can do, I can take this C and A and B, all of them in one side. I can write this as the concentration of C to the power C, concentration of D to the power D, divided by concentration of A to the power A, divided by concentration of B to the power B. And then I can write for RT, I can write here C plus D, and for the denominator I can write RT A plus B. Now this can be written as, so this whole part here, CCDD divided by AA and BB. What this is KC. This is nothing but this is the KC, right? So this is KC. And what is this? I can write this RT to the power of delta number of moles of gases, because we are taking gases. And what is delta Ng? Delta Ng is equal to the number of moles of product minus moles of product. I mean, what only for gas? Okay, moles of gas moles. Okay, gas for gas. This is also moles of gas in reactant. And obviously, if I have started with Kp, that means all A, B, C, D, all of them should be in gas state. This is delta Ng. This is delta Ng. Write this down. Let me know if you're done. Write this down. Let me know if you're done. Okay, write a note here. Now we can say now we can say that Kp is equal to the equilibrium constant in terms of the concentration times RT to the power of delta Ng. Now here you have to note the value of R. Okay, the value of R. R is equal to 0.0821 liter ATM per Kelvin per mole. That means if the gases, if the reactants and the products are given in terms of ATM, then you will use R is equal to 0.0821. The other case will be if you are given in bars, then you will write 0.0831 liter bar per Kelvin per mole. Okay, so please remember these terms. 0.08821 if you have ATM. देखिए ऐसे याद कर लीजिए इसको. You learn it in this way. A, then 2, B, then 3. है ना? 0.821 when you have ATM. 0.831 if you have BAR bar. Okay. So if A is there, that means ATM is there. That means you will have 0.821. If bar is there, then you will have 0.831. Now write a question. The concentration of the concentration of reactants and products of following equation, following reaction are given. So the reaction is if you have N2 gas, and you have O2 gas, and you are going to get what you are going to get 2 moles of NO gas. Okay, so are given. What are the concentration? So we have N2, which is equal to 3 into 10 to the power -3 molar. You have O2, which is given as 4.2 into 10 to the power -3 molar, and the number of moles of NO, it is given as 2.8 into 10 to the power -3 molar. Calculate the equilibrium constant. Which equilibrium constant? Kc. Equilibrium constant Kc for the following reaction. For the following reaction. You guys can do now. First of all, you will express the Kc, which is equal to the product concentration raised to the stoichiometric coefficient divided by the reactant. I should write this as equilibrium, no? Wait a second. I need to reshare this thing. Yeah, write this down. Let me know if you're done. So you will calculate the equilibrium constant Kc. It will be one value. You will send it in chat. Okay. You will send it in chat.
हो रहा है आतिफ, सूरत, रीबा, मोहम्मद उमर. हाँ guys.
Yes, sir.
Okay. What about you guys? Huh? Surat? Yes, Surat. Okay. What about you, Atif?
Calculating.
Okay. You got the expression, Atif? You got the expression? Equilibrium, constants expression?
Yes, sir.
Okay. What about Muhammad Umar?
As I'm doing.
Okay. You got the expression, na? Muhammad Umar?
Yes, yes, sir.
Okay. Okay. Yes, Reba. Correct. Very good.
Okay, another answer. Yes, Atif, very good, correct. No answer till now. Reba, what happened, Reba?
Yes, sir.
Yes, sir. Acha, Reba nahi. Sorry, Surat. Really sorry, Reba. Surat.
Yes, sir.
What happened? नहीं हो रहा है?
सर मैं ट्राई कर रही हूँ, बार बार मिस्टेक हो रही है।
ये क्या है? बार बार मिस्टेक हो रही है. Did you write the expression, Surat? Did you write the expression for KC? Okay, I got one answer. Okay. You write slowly, huh? You do the problem slowly, but still not very slowly. You have to optimize. Okay, another answer. Let us see. Okay, Surat, turn the mic on. Surat,
Yes, sir.
tell me what is the expression for KC? What did you write? Okay, tell me. Say, repeat with me. Products upon react. Repeat.
Raised to the power 2.
Sorry, tell me.
And raised to the power 2.
NO, the concentration of NO. Okay.
Yes, sir. The concentration of NO.
Okay. Square divided by
N2.
N2.
O2.
O2. Now tell me, what is the concentration of NO? What is the concentration of NO that is given?
2.8 into 10 raised to the power minus 3.
Minus 3 molar. Okay.
Yes, sir.
Whole square. Okay. So rather than writing whole square, what I like to do is, okay, I need to reshare my thing. Okay. I don't write square. Okay. I don't like squares because that's not easy to calculate. Okay. I write it like this. No problem.
Yes, sir.
No problem, right? Molar. What is the concentration of N2?
3 into 10 raised to the power minus 3.
Is 3 molar into
4.2.
4.2 into 10 to the power minus 3 molar. So what are the things that I can eliminate? Can I eliminate molars? Yes or no? All of
Yes.
this? Okay. Then what next I can eliminate? So see, this is the sequence that you will keep. Okay. First thing that you will eliminate are the units. You will solve the units. Second, you will solve the power of 10. After that, you will solve the numbers. Okay. So this is the order that you are going to follow. So first of all, we have taken care of units. Next is we will take care of the powers of 10. So 10 to the power minus 3 and 10 to the power minus 3 is going to cancel. 10 to the power minus 3, 10 to the power minus 3. It's going to cancel. Yes or no? Any problem till here?
No, sir.
Tell me, Surat. क्या तो कहाँ हो रही थी प्रॉब्लम आपको? हाँ, यहाँ तक किया था आपने?
Yes,
बताइए,
sir.
यहाँ तक किया था आपने. अच्छा. So what did you write next? 2.8 into 2.8, right? 3 into 4.2. So what do you think? Which is cancel होगी यहाँ पे कि नहीं होगी? Is there anything that is that's going to get cancelled? Yes or no? Tell me that.
2.10 and 4.2.
Okay, how will you cancel this? Tell me. Tell me. You're dividing both of these things by 2?
Yes, sir.
Okay, you are dividing both of these things by 2. Okay. But I have a better idea. You can do what? You can divide both of these things by also 7. So 7 4s are, that means 0.4s are 28 and 7 6s are 42. Na? So 0.6, 42. Then you can also eliminate these two by 0.2 and this will be gone by 0.3, right? This will be gone by 0.3. Now you have 2.8 times 0.2 divided by 3 into 0.3. So 8 to the 16, 28 plus 28, right? So 25 plus 25 is equal to 50. 3 plus 3 is 56. So this will be 0.56, na? Yes or no? 0.56? 0.056, 0.56. Yeah, 0.56 divided by 0.9. Correct?
Yes, sir.
So now
0.8.
0.8. 0.6, na?
Sorry, 6. Sorry.
0.6. And there will be something left also, right? So 9 and 56 you can directly divide. So you will write 6, which is equal to how much? 54. Then you will write 2. So you will have zeros here. So you can write 2. So 6.2222 it will be like this, I think. 2, 18, 2, 18, 2. Yeah. So this is the answer. क्या दिक्कत हो गई? हाँ? It's very bad. It's very bad. हाँ? क्या mistake? बताइए what mistake? Tell me. Multiplication था ना?
Yes,
Surat,
sir.
I can expect na that you can do multiplication. Should I
Yes.
not expect that?
Yes,
Huh?
sir.
Same thing goes for Abhinav. Same thing goes for Muhammad Umar also. Those who have not given the answer. So like while explaining, I did not take, the amount of time. So like I think 5 minutes or so I took with explanation. Without explanation, you can do this in 2 or 3 minutes. You have to do this in 2 or 3 minutes. Okay, maximum
2 or 3 minutes. Now, whatever you are doing in equilibrium, my responsibility is that you understand what is going on. Okay. And definitely I will make sure that you will understand what is going on, what are each terms, and I will try to make you feel about equilibrium, what is happening, what is not happening. I will translate each and everything that is in chemistry to English, plain simple English, but calculation. I cannot help you in calculation. You have to take care of the calculation part. I can give you some heuristics and some rules that you will first of all calculate units and power and then the numbers. One more thing that I say is that you do the rough, whatever you are doing now, they should be in same page. Whatever rough calculation you do, for example, I divided now, so I did not divide in the back side, right? I did not divide anywhere else. And I divided like this 9 divided by 56. Same page and same size of font you will use for the rough work also. Okay, so these are some rules that I can tell you that will help you in just tracing the mistakes where you are going wrong. So these are not error proof. Okay, if you use this, it doesn't mean that you will not be doing any mistakes. You will be doing mistakes, but you will be able to find that mistake. That's it. Calculation you have to do. Equilibrium is all about calculation. It does not have much theory. Okay, it does not have much theory as questions. Okay. Okay, so we did one question regarding, we did one question now. And what else then? What did we do earlier than that? Okay, fine. So now in this question, you saw that there is no units for equilibrium constant, but this will not be always the case. Okay, this is only happening because if I look at the number of moles of gases or number of moles of things involved in the gas, in the reactants and product, they are same. So 2 moles in the reactant, 2 moles in the gas. That is why you have unitless equilibrium constant. But so note here that what should you write? The equilibrium constant has no units. Equilibrium constant is unitless. Equilibrium constant is unitless when the number of moles of reactant and products are same. When the number of moles of reactants and product are same. But if I will have, but if they are different, then what will happen? Then equilibrium constant would have some specific unit, some specific units. No. So whatever equilibrium reactions that we are going to see, we can divide that into 2 parts. Okay. So equilibrium, chemical equilibrium, it can be divided into 2 parts that involves reactions. So it can be either homogeneous or heterogeneous. Okay. So write this. Easy things are homogeneous, and there will be some which is heterogeneous. Homogeneous equilibrium and heterogeneous equilibrium. Right here. Now, in homogeneous equilibrium,
Can you scroll up, please?
scroll up. Okay.
Just the note part, sir.
Okay, right here. Products and reactants both are in same phase. All products, okay? All products and reactants are in same phase. Heterogeneous products and reactants are in different phase.
Done. Homogeneous, heterogeneous. Guys.
Done, sir.
Okay. You don't have to write
Can you
this.
scroll up?
Yeah, sure. But you can write na homogeneous, heterogeneous equilibrium. Products and reactions same phase, different phase, nothing else. Simple. Done, Umar?
Yes.
Okay. Now see this question. Surat, you tell me. A, homogeneous or heterogeneous? A. Surat, turn the mic on and tell me, is this heterogeneous or homogeneous?
Homogeneous.
Reba, D, heterogeneous, homogeneous.
Homogeneous.
Muhammad Umar, heterogeneous, homogeneous.
Homogeneous.
देख के तो बोलिए. I will kick you
Sorry,
out of
yeah.
the class if you say like this type of answers. Okay. Simple things I am asking, hai na? I expect answers from here. Now tell me for this, Atif, heterogeneous or homogeneous? Atif, are you here?
Sir,
Tell me.
so it's homogeneous.
Okay. Why not homogeneous? Why not heterogeneous? You can see liquid is there.
Sir, because it's water and all the other.
Everyone is water. Yeah, correct. So if you have aqueous, this is also aqueous. Okay. Water means aqueous means water only. The E will be what? E is aqueous and aqueous. And what is this? This is solid, right? So this will be heterogeneous. Okay. Fine. So you don't need to write this. Okay. I just wanted to show you guys. Now, for example, if I take this, for example, let's say, if I want to write for write a note. If you will ask me a question, then I will explain this. Write a note. By convention, the concentration of pure liquid and solid, pure solid, okay? Pure solid in a chemical reaction is taken as unity. It's taken as unity. Unity means 1. That means the concentration of solid will be equal to 1, and the concentration of liquid will also be equal to 1. If you have pure liquid, okay, it will be equal to 1. So for example, if I have a reaction such as CaCO3 solid, which is in equilibrium with calcium oxide, which is solid, plus CO2 gas, then you must be tempted to write that Kc, which is equal to the concentration of product. In the concentration of product, what do we have? We have the concentration of CaO, right? And we have the concentration of CO2. In the reactant, we have the concentration of CaCO3, right? But since these two, oxide and carbonate, these two are what? These two are solid. So these will be equal to 1. Okay, since the concentration of CaO and the concentration of CaCO3 is equal to 1 now, because they are pure solid. So the Kc for this type of reaction, this will be equal to what? This will be equal to just CO2. And because if I plug in 1 instead of CO and CaCO3, then we will get only CO2. Write this down. Let me know if you're done. You can also write that Kp will be equal to the pressure of CO2. The Kp, this will be equal to the pressure of CO2. That's it.
Sir, what exactly does pure mean in this case?
It means that if in the reaction they have written liquid or solid, that's it. That means it is pure liquid and pure solid. जैसे हमने यहाँ पर लिखा ना reaction
So
में.
it should not be aqueous or something like that?
No. If it is aqueous, that means it is in water, na. It is a solution. It is not pure.
Okay.
Na? Liquid means if you have L written somewhere here, CaO, or if you have pure liquid means H2O liquid, for example. Yeah, H2O liquid. Okay. Write this down. Let me know if you're done. Done, guys?
Done, sir.
Okay. Write homework. You don't have to write this, just take a screenshot. Okay, this will be also uploaded in the. So as you can see that you need to ignore things like solid, the solid in the Kc expression, the solid, this complete liquid. Then you have this is liquid, pure liquid, right? So these are the things that you need to ignore. Okay, this will be uploaded. Take a screenshot fast. I'm just waiting for 5 seconds. 5, 4, 3, 2, 1. Okay. Now, right, application of equilibrium constant. Application of equilibrium constant. Before that, let us try to let us take a point and understand what is the ratio. Okay, the ratio that we said now, the ratio of product and reactant raised to there is stoichiometric coefficient, right? So the ratio of products and reactant raised to their stoichiometric coefficient, stoichiometric coefficient, generally is known as the reaction quotient. The reaction OTIENT, reaction quotient. That means Q is equal to the concentration of products raised to their coefficient, pi. That means you have to multiply all the products divided by the reactant. Okay, raised to their stoichiometric coefficient. This is what generally this is known as the reaction quotient. That what does mean generally? At all time. At all times when the reaction is happening, when the reaction is not happening. So this is known as the reaction quotient. But at equilibrium means when the concentration are not changing after a very long time, when the reaction has started and then the concentration of products and reactants are not changed. But at equilibrium, when you make this ratio at equilibrium, this Q is known as the equilibrium constant. This Q is known as what? The equilibrium constant. Okay, so just I have introduced this expression, that is Q, nothing new. It's the same thing. And what is K? K is a specific moment. Achha, also one more thing, equilibrium is not one point. Okay, it is not one moment. It is after a very long time.
when nothing is happening after a very long time. Okay, equilibrium point ऐसा कोई point नहीं होता है. Okay, so we have also seen in the previous lecture that when you will have the rate of forward, rate of backward reaction. So whatever is after this now, after this, all of these are equilibrium states. Okay, so after this you have achieved the equilibrium state. You don't need to know what is the point. Time has nothing to do. Okay, never worry about time when you are learning about equilibrium. When you are learning about equilibrium, never think about time. Time factor will only come when you are dealing with chemical kinetics in 12th standard. Okay, did you write till here? Tell me, then I will start. Guys, yes or no? Done? Not done?
Answer.
Not done, then take screenshot. हम नहीं रुकने वाले. इतना टाइम बर्बाद किया आपने. मेरा तो इतना गुस्सा आ रहा है, इतना गुस्सा आ रहा है, क्या बताएं. I asked you guys to express ना equilibrium constant. आपने इतना टाइम ले लिया मेरा, बताइए. You guys have to wait. Right, number 1. Prediction of the extent of reaction. The extent of reaction. Okay, so what does this mean? Extent of reaction, क्या मतलब इसका? Extent of reaction, what does this mean? Anyone will tell me? Extent of reaction, what does this mean? How far the reaction will go. Okay, how far the reaction will go. For example, if I have A to B, if I have a reaction in which A is converting to B, okay, A is converting to B. Let us take equilibrium reaction because we have, okay, A to B. Now, if I will say that I started with 20 moles of A, and if I started with 20 moles of A, and after a long time, so this is initial, and at equilibrium I saw that there is 0 moles of A and 20 moles of B. That means the extent of reaction. What is the extent of reaction? The extent of reaction is large. That means this can go a very large part. Okay, that means the change in the concentration of product will be going to be very high. Okay, so how far the reaction will go? That means how much of the product is going to be formed. So how will the equilibrium constant tell me about the extent of reaction? You understand what does it mean by extent of reaction? Yes or no? Guys, Atif, Reba, Surat, Muhammad
Yes,
Umar.
sir.
Okay, extent of reaction means how much of the reactant it is going to. Now if I say the extent of reaction is small, that means none of the reactant will get converted into the product. If the extent of reaction is very large, that means all of the reactant will be getting converted into product. All of the reactant will be getting converted into product. Now let us understand what is Kc. If I say Kc, it is equal to 60. Okay, what did I say? Kc is equal to how much? Tell me, guys. 60. If I have a reaction, simple reaction I'm taking, okay, this is a generalized case, A to B, okay, A to B, then Kc, it is also equal to the concentration of B divided by the concentration of A. Yes or no? Yes or no?
Yes, sir.
That means I can say at equilibrium, after a long time, after a very long time, at equilibrium, when the reaction started, then after a very long time at equilibrium, for each mole of A, for each mole of, you can say for each mole of A, no problem, because the volume will get cancelled. For each mole of A, there are 60 mole of B. Yes or no? Yes or no, guys?
Yes.
Yes,
Tell
sir.
me. Yes. Okay. So please understand what the equilibrium constant tells you about. It tells you about how much product will be there for each mole of A. Okay, this is a very generalized case because I'm not taking into consideration anything. I'm taking a very simple, the simplest of reaction. 1 mole of product is going, 1 mole of reactant, it is going to give me 1 mole of product. But you see that the reactions are not like this. Okay, so there are complex reactions. So in that case, there will be some difference in the specific definition of what we are understanding as equilibrium constant. But essentially, I can say that if I have a high K value, that means if the equilibrium constant is very high, that means at equilibrium, what is going to be more? The product is going to be more. If the product is going to be more, that means if I start a reaction, keep it for a very long time, then most of the product are going to get converted into what? Into most of the reactant are going to get converted into product. So from here I can say the equilibrium constant, I can divide that into 3 parts. Okay, the ranges. So you have equilibrium constant, that is K. Okay, now if I say the K is less than 10 to the power minus 3. Okay, it is less than, right, K, it is less than 10 to the power minus 3. What will happen in this case? In this case, you can see now, so it is 10 to the power, so 1 upon 10 to the power 3. That means which is more, reactant is more or product is more? K is equal to this much. So tell me what is more, reactant or product? Huh? Atif, Najib, Reba, Surat? Don't know. Hi, Allahu Akbar. Tell me the expression of K, Atif. Atif, tell me the expression of K.
The concentration of D by concentration.
Okay, I am saying now Kc is equal to 10 to the power minus 3. So this is equal to 10 to the power minus 3. Now, so 10 to the power minus 3 is equal to what? 10 to the power 1 upon 10 to the power 3. Yes or no?
Yes, sir.
Now tell me what is more, product or reactant? What is more? Array, what happened?
Reactants.
Reactant is more. So the extent of reaction is small. Right? The extent of reaction is small. I can say, yeah, small extent. Small extent. And at equilibrium, what will happen? What will be more at equilibrium? Product or reactant at equilibrium? What will be more? Array?
Reactant.
Thank you very much. Reactant will predominate. Okay. And if you have K, which is greater than 10 to the power 3. Okay, this is 10 to the power 3, this is minus 3. In this case, the extent will be large extent of reaction. And at equilibrium, products will dominate. It means that all of the reactant will get converted into product. Products will dominate. Then there can be also a case in which you will have the K, which is less than 10 to the power minus 10 to the power 3, but it is more than 10 to the power minus 3. So in between these two values, then what I can say, both the reactant and product will be present in appreciable amount. Appreciable amount means measurable amount. Appreciable amount at equilibrium. Okay, at equilibrium. Now, in this case, if the K is very small, the reaction doesn't start. Reaction hardly starts. Reaction hardly starts. Okay. Now, in this case, if the K is very high, reaction goes to completion. Reaction goes to completion. Write this down. Let me know if you're done. Or take a screenshot if you're not done. Right, next.
predicting the direction of reaction.
The time is over.
Time is over. No problem. I know time is over. Predicting the direction of reaction. अभी तो बैठिए आप लोग. Predicting the direction of reaction. Okay. Now in this case, let us suppose you have this type of reaction. Tell me what will be the K. I can express the K as concentration of B upon concentration of A. Okay. And I am giving K is equal to let us say 1. Okay. K is equal to 1. Now, predicting the direction of reaction means you are given some initial concentration of A and B. Okay. You have started with some amount of A and you have started with some amount of B. So you have taken some amount of A and B and then you have put it here. And you want to know now, given that amount of A and B, where is the reaction going to proceed? Will A get reacted? Will the concentration of A will decrease and B will increase, or it will happen the other way? Okay, so let us give an example. Okay, now translate this in English terms now, guys. If K is equal to 1, what does that mean? For each mole of A, how many moles of B? For each mole of A, how many moles of B? Atif, Reba, Surat, what happened? Don't know? If you guys are not going to give answer, I can keep on going, okay? I have to complete the things now. I can keep on going. You tell me fast. Do you know this or don't know this? Atif, Reba, Surat, Abhinav. Guys?
So can you repeat? Don't provide.
I am asking for each mole of A, how many moles of B will be there if K is equal to 1?
The same amount.
Reba? Arey, Reba, I'm asking you something now. Can you please turn the mic on at least?
Yes, sir.
Okay. You know now, I can write this as the concentration of B upon A. Yes or no? So now you can't see that at equilibrium, I'm saying the amount of B and amount of A will be same. Then only we will get 1, na?
Yes, sir.
So please write this, okay? Please write this somewhere if you don't understand this, because I have said the same thing here, okay? So this should be in your mind. Equilibrium constant is nothing, it is just that. Please understand this, okay? If I am writing equilibrium constant is equal to something, that means it is equal to the amount of A. Very generalized thing, but still. Now let us take one experiment. Please keep your mic on, Atif and Reba. Okay. What is the initial concentration of A? What is the initial concentration of A that I have taken?
20.
What is the initial concentration of B that I have taken?
5.
5. Okay. Now, if I will start this reaction, okay, the reaction has started, then what do you think? What will happen? A will be getting converted to B or B will be getting converted to A? Because it can go both directions. Tell me. What do you think? What is going to happen?
A will get converted to B.
A will be converted to B. Why? So listen. Equilibrium, it predicts the future, okay? What does it do? Equilibrium? What does equilibrium do? Predicts the future. Okay, that means if I start a reaction, what is going to happen after a very long time? Okay, what does equilibrium do? It will tell us what is going to happen after. What is going to happen after a very long time? Yeah, thank you very much. After a very long time. Okay. So if I start with A, which is 20, and if I start with B, which is 5, I have taken that both of them in one container. And the equilibrium constant, it is saying that at equilibrium, what is going to happen? At equilibrium, what is going to happen? The amount of B should be equal to the small amount of A. This or no? This is what
Yes, sir.
equilibrium is saying. Okay. So what does have to happen now? If I want to keep both of the amount equal, then what should happen? A should get converted to B or B should get converted to A? To make both of things equal, what should happen? The reaction will start now. Then where will it go? A will be converted to B or B will be converted to A? Huh, Reba?
It will be converted to B.
A will be. All of you understood this? अच्छा, रीबा आपकी स्कूल में हो गया है क्या इक्विलिब्रियम?
Yes, sir. We just finished the chapter.
इसीलिए आपको कुछ आपने वहां पे ध्यान लगा के पढ़ लिया है क्या?
No, sir.
अच्छा, क्या ज्यादा ध्यान लगा के नहीं पढ़ा आपने? Okay. So now you understand, na? Now see. If I will take, let us say, just opposite. A is equal to 5 and B is equal to 20. Given that the K is equal to 1, that means after a very long time, what is going to happen? The amount of B and amount of A are going to be same. Now tell me what will happen? The forward reaction or the backward reaction? Which will happen?
Backward.
Backward reaction will happen. Okay. Now what we will do, we will take a generalized case and we will say that at this position, at initially, what we can write? We can write the Q, right? So when I write the Q, this will be equal to what? 5 upon 20, which is equal to 1 by 4. Okay, this is the initial. That is why I have written Q. We can write Q only when it is not in equilibrium. If it is in equilibrium, that means it will be K. If it is not in equilibrium, then it will be Q. It will never be K. It will never be K. Okay. Similarly, what will be the Q here, guys? Tell me. The Q will be equal to, tell me. Fast.
20 by 5.
Very good. 20 by 5, which is equal to
5.
4.
4.
4. Okay. 20 by 5, na? Which will be equal to 4. 20 by 5, which will be equal to 4. That means I can say that. That means I can say, now in this case, what was happening? Forward. In this case, what was happening? Backward. Now, when I compare these two quantities with the K, so I can take one case. In the first case, the QC, that means the reaction quotient in terms of concentration, if QC or anything, okay, QC or QP, if QC is what it is, smaller than K, what is going to happen? Forward reaction. Forward reaction, and the reaction will go rightwards, right? Right direction. Rightwards. Okay. Secondly, if I have QC, which is greater than the equilibrium concentration, then what is going to happen? Backward reaction, that is leftwards.